Hello everybody. In this session, we will be doing one more board question from the Anna University paper which has appeared in 2004 and 2011, which is just write the expansion of x cube plus y cube plus xy square at 1, 2. As I told you, this is a section B question. So can you judge how many terms you are supposed to write? Yeah. You must be writing up to the third term because it is in section B. Look at the number, look at the marks and then attempt the question. If it is in section A, as I told you, you can stop with 2 degree, and if they tell you stop at that place, if they did not say anything, look at the section or look at the marks and then decide. Okay, if it is a high mark question in section B, do up to this. Otherwise, you do up to this if it is in section A. Okay. So your f of xy is x cube plus y cube plus xy square at 1, 2. So clearly you are given A and clearly you are given B. Okay. So once both the values are given, you have to start doing the question. So first is f of a comma b, which is f of 1, 1 is 1 cube plus 1 cube plus 1 into 1 square. This is 1, 1, 1. Everything is 1. So this is 3. So you will write down f of 1, 1 is 3 and keep your answers ready. Okay. So I'll write it here. F of 1, 1 is 3.
X square is 2. Xy square is 2 square.
Oh, from this only. So you are going to substitute, first find the value of f of a comma b. So what is f of a comma b is 1, 2. So plug in x is 1, plug in y is 2. So this is 1 cube plus 1 cube plus 1 into 2 square. So 1 plus 1 is 2. This is 4. So 4 plus 2 is 6. So f of 1, 2 is 6. Draw a rectangular.
Y cube, 2 cube.
The question there. Can I? So f of beginning only. F of xy is x cube plus y cube plus xy square. Okay. So now I am going to plug in, find the value of f of ab. So f of 1, 2. F of 1, 2 is substitute x place 1 and y place 2. Okay. So 1 cube is 1, 2 cube is 8. This is 4. Okay. 8 plus 1, 9, 10, 11, 12, 13 is the answer. So f of 1, 2 is 13. Okay. So let me write it down here. F of 1, 2 is 13. Now I need to do fx of AB. Okay. So let me do fx of xy. Write carefully. When x means write neatly, so later you don't have problem. Fx of xy means I am going to differentiate this partially with respect to x. So y is a constant. So x cube derivative is 3x square and y cube is a constant. So its derivative is 0 plus y square is a constant. Write it as it is. Derivative of x is 1. Okay. So fx of xy is 3x square plus y square. So what is fx of 1, 2? Plug in x place 1 and plug in y place 2. This is nothing but 3 plus 4 is 7. So fx of 1, 2 is 7. Okay. So let me note it down here. Fx of 1, 2 is 7. After completing also, you need to stop properly. Okay, as I taught you in the previous question, when x minus 1 whole square, all of them will stay as it is. Okay, same way after you calculate this, when you stop the question, you better stop in the way they have asked us to stop. Okay, so let me erase this one part. Okay, now I have to do fy of AB. So for that, let me do fy of xy. Fy of xy means x is a constant, so this derivative is 0 and this y cube derivative is going to be 3y square plus x is a constant and y square derivative is 2y. Now I want fy of 1, 2. So plug in y place 2, plug in x place 1. Okay, and this is 4 times 3 is 12 plus 2 times 2 is 4 and 12 plus 4 is 16. So you will note down fy of 1, 2 is 16. Draw a rectangle and keep it ready. Okay. Now let me write x into 2y as 2xy. Okay, this is nothing but 2xy. I just erase it and write it neatly. 2xy. Okay. Now coming to the next line, you need fxx of AB. Okay, so first I'll do fxx of xy. So fxx of xy, which is the derivative of x with derivative of this line with respect to x partially. So 3x square derivative is 6x, and what is the derivative of y square is 0. Why? Because it is a constant. Okay. Now fxx of 1, 2 I need for substituting. So fxx of 1, 2 is 6 times 1 is 6. So fxx of 1, 2 is 6. So fxx of 1, 2 is 6. Now, you know A is 1 and B is 2. Okay. Now, fxx of xy is done. Now you need to do fxy of AB. Okay. So for that we will do fxy of x, y. What is it equal to? We have differentiated with respect to x, and now I am going to differentiate this line with respect to y. Okay, when you do that, 3x square is a constant because we are differentiating with respect to y, and y square derivative is 2y. And now I need fxy of 1, 2, which is 2 times 2, which is 4. So fxy of 1, 2 is 4. So keep it ready. Now, next we require fyy of a, b. Okay. So fyy of x, y. Okay. So I am going to differentiate this y line. Okay. Now, when I am going to differentiate this y line, okay, fyy of xy. So I am going to differentiate this with respect to y. Okay. So when I differentiate this with respect to y, I am going to get, this is a variable. So 3y square derivative is 6y plus, you know, 2x is a constant. So let me write it as it is, 2x, and y derivative is 1. Okay. So 6y into 2x constant written as it is, derivative of y is 1. So now I require fyy of x, a, b, which is 1, 2, which is 6 into 2 plus 2 into 1, because x is 1 and y is 2. So this is 12 plus 2, which is 14. So Fyy of 1, 2 is 14. So draw a rectangle and keep it ready for you. Let me write it here for my reference. Fyy of 1, 2 is 14. Okay. And I am erasing this one part 1 because 2x times 1 is 2x. So I am just erasing it. Okay. Now let me do f triple x of x comma y. Okay. So f triple x of x comma y is nothing but I have to differentiate this part with respect to x, okay, because 2x is done here, one more x I have to do. So this is 6x, derivative of 6x with respect to x is 6 and we are differentiating it partially, so this is 6. So f triple x of 1, 2 is also 6 because we don't have anything to substitute for x and y. So f triple x of 1, 2 is 6. What do we want next? F 2xy. Okay, f x y. Write neatly. It should look like x and y. Okay, of x and y equal to. What is x? I have to differentiate this xx line with respect to y, and you know x is a constant, so 6x derivative is going to be 0 for you. So fxxy of xy is 0. So fxxy of 1, 2 is also 0. fxxy of 1, 2 is 0. Moving on, I need fxyy. Okay, so for that, what should I take? Xy I should take. Where is xy? Here is xy. Okay, xy is here. I should differentiate it with respect to y once more. So xy term is here. So this one I am going to differentiate with respect to y. So fxyy of xy is, this is in terms of y, we are finding the derivative with respect to y. So your answer is 2. And fxyy of 1, 2 is also 2, because when you have x and y, you will substitute and get the answer. When it is a constant, for any value, fxyy is 2. Is 2. Now, the last one, I need to calculate f triple y of a comma b. So, f triple y of x comma y, let me do first, and for that I should go and search where is yy. Okay, yy is here. Okay, fyy is here. I should differentiate this with respect to y partially. So when I differentiate this with respect to y, I'll get 6, because the reason 2x is a constant, and what is the derivative of 6y is 6. So fyy of 1, 2 is 6. So we have calculated everything related to our problem. 1, 2 is 6. Okay, once we have written down everything, just we need to plug in, and you should know how to stop the question. That's all. Okay, so let me erase everything and just write the expansion. So f of xy is nothing but f of ab, 13 plus 1 by 1 factorial into x minus a. Your a was 1. fx of ab is 7 plus y minus b. Your b was 2 fy of AB is 16. Close it. Plus, you also write only this much in the first line, write the second one in the second line. If you start writing in your page also, it will not be sufficient and you will be folding it, writing, and it will be confusing. So better write this alone in the first line, second line and third line. Okay. So it looks neat and the calculation is easy to start with. Okay. Neatness is one side, you have to identify your own calculations for that reason. X minus a the whole square is x minus 1 the whole square fx of 1 2, which is 6, plus 2 into x minus 1 into y minus 2 into fxy, which is 4, plus y minus b is y minus 2 the whole square into fyy, which is 14, plus move to the third line, don't write it in the same line, x minus a, x minus 1 the whole square f triple x is, sorry, x minus 1 whole cube into f triple x is 6, plus 3 into x minus 1 the whole square into y minus 2 into fxxy, fxxy is 0, plus 3 into x minus 1 into y minus 2 the whole square into fxyy is 2, plus y minus b is y minus 2 whole cube into fyy 1 2 is 6. Just plug it in there and then just put etc. Okay. So how we are going to stop it is, just write these terms together, y minus 2 terms together, these terms in the middle. Okay. So let me write it down. So this is 13 plus, you know 1 by 1 factorial is 1. Okay. So 7 into x minus 1 plus 16 into y minus 2. 7 into x minus 1, 1 into this, plus both the places, so plus 16 into y minus 2. So this part is done. Come to the second line. 1 by 2 factorial into, I told you to write it in the next line, so I will also do the same thing. 1 by 2 factorial into 1 by 1 we are multiplying now, okay, into x minus 1 whole square into 6, sorry, yeah, x minus 1 whole square into 6 plus 1 by 2 factorial into 4 into 2 is 8 into x minus 1 into y minus 2. Just I am going to copy it down. 2 factorial into 8 into x minus 1 into y minus 2 plus, because this is plus into plus is plus, and 1 by 2 factorial into this term. Okay. So 14 into y minus 2 the whole square. So second line is completed. Coming to the third line, plus 1 by 3 factorial into, this is 6 into x minus 1 the whole square, the whole cube, sorry, 6 into x minus 1 the whole cube plus 1 by 3 factorial into, actually this is 0, so it is nice for me, no need to write. So 1 by 3 factorial, let it be there, we are going to write for this term. Okay, 3 times 2 is 6 into x minus 1 into y minus 2 the whole square plus the last term 1 by 3 factorial into y minus 2 the whole cube times 6. Okay, 1 by 3 factorial into y minus 2 the whole cube times 6. Okay, now let us check which terms are getting. 7 into x minus 1 plus 16 into, I am just noting it down, that's all, plus x minus 1 3 times x minus 1 the whole square plus 4 times x minus 1 into y minus 2 plus 7 times y minus 2 the whole square plus x minus 1 the whole cube plus x minus 1 into y minus 2 the whole square plus y minus 2 the whole cube plus etc. Okay. So we have expanded the given question x cube plus y cube plus xy square with a and b as 1, 2 in terms of x and y, and we have done up to cubic polynomial because it has appeared in section B question. Okay. I think it is clear for you, and hope you have memorized the formula also correctly. Practice few more sums and attempt this question in the exam.